Okay, YouTube, Todd here again, some guitar guy. First off, thanks for watching. So, in a previous video, we talked about the kind of a quick check and fix of the auto decompression system on the Suzuki Savage, Boulevard S40, LS650, all the same bike, all the same system, all the same part numbers. The only thing that I can see that changed over the years was these mounting bolts. Mine don't have this hex, doesn't have this hex head bolt. So what is a decompression system to begin with? Well, these have been around 100 or so years as displacement and, of course, compression increased over the years in early bikes. Engineers realized, hey, these things are getting hard to, and of course, there were no electric starters. It was all your right leg. But engineers realized the need for a starting aid in the form of a decompression system. So that's how they were kind of born. The early bikes had a lever, usually on the left handlebar, either operated by your thumb or your fingers on your left hand, and the starting process. And of course, riders knew this. This was, I don't know, this was part of riding a motorcycle, and cars were much more user involved too. But you rotated the engine over with your right leg until you found the compression stroke, and you knew, because it got a lot harder to rotate the engine, did all your pre-start stuff, set the choke, maybe retarded the timing, which was manual. I think some even came with a mixture adjustment. And then as you kicked down on the Kickstarter, you activated the lever to decompress the engine, and then almost immediately released it. So you just wanted to get through that first compression stroke, because the engine's not, it's not going to run decompressed. And then hopefully on the next one, you've gotten it up to that critical speed with your initial kick, and the engine will fire and you're off on your way. So Suzuki has replaced that with this automated system, and automated systems come in different forms. There's this electromechanical system Suzuki used, but there's also like an internal camshaft spring-loaded system, which it seems to be much better, and I'm sure kind of simpler, better, and probably less prone to failure. But here we are looking at the solenoid with the boot removed, the measuring plunger. Here's the actuator. You can barely see the cable, and you can see a part of the relay here. So, and this is the adjustment process, which I'll go through in a little bit more detail. But it's pretty simple in a way, complicatedly simple. You have to remove the valve cover, remove the seat, remove the tank, remove the little chrome head cover, rotate the engine over to TDC on the compression stroke, so all the valves will be closed, and then measure the throw of this rod. It seems a little bit complicated. You need to remove the valve cover to make sure that you're on the compression stroke. But the way this thing works, let me get back one slide. Okay, well, we'll start here. So here's the relay. So in this version, the relay replaces your brain, and it controls both the decomp system and the starter. So you press the starter button, the relay knows you're trying to start the bike, so it sends power first here for 0.2 of a second before powering the starter. This activates the system. It goes into this position, tensions the cable, decompresses the engine, and then at the 2/10 of a second mark, the starter turns. So it's not timed with your engine. It really doesn't know what stroke the engine's on. But I suppose the thought is in that half second of activation that it should decompress at least one compression stroke, and then at 7/10 of a second total time, the relay cuts power, the decomp system deactivates and returns compression to the engine. So when this cable here is tensioned, this runs across the top of the head to the left side of the bike. It goes to this linkage. Now, the chrome head cover is also removed. You'll only be able to see the end of the cable and the top adjusting nut. You won't be able to see all this. It'll be covered by the chrome trim, complete with a little notch, a little cutout. So the system activates, tensions this cable upward, so it rotates this lever and shaft toward the front of the bike, right? And you see it's spring loaded so that it will return to the inactive position. When it rotates this shaft, okay, this turns downward, this little notch, and presses down on the rocker and cracks open both exhaust valves, because the rocker connects the two valves. And your engine's decompressed, and again, the clearance here is 3 to 5 millimeters if you care to go through the shop manual's procedure to do such. So it's simple, but it's also kind of complicated. And the weak point in all this is not the solenoid itself failing, but getting dirty. Now, these are pics from the first video with all my goop of that penetrating lithium grease. So, as promised, this is a little bit more detailed of a more permanent fix. And I don't know that you can permanently eliminate this. There was a comment in the other vid about attaching like basically some kind of a skirt that may or may not help. I don't know. I think the long-term fix is just to make this a part of your spring cleaning. Monitor it. If you stop hearing the solenoid activate, or experience hard starting, or any of the other symptoms, then it's probably time to take it this next step. So to get here, and it's not terribly difficult, you'll have to remove the seat, the 3 bolts that hold it, the 2 bolts for the tank, wiggle the tank off its rubber mounts, then 2 bolts here to take the solenoid basically apart, or as far as you need to take it apart, and just basically clean it and use some type of a protectant, hopefully as a lube, and maybe mitigate some corrosion. So you see here my penetrating lithium grease worked quite well. It penetrated really well. So you just remove those 2 bolts and it and the electrical connection, and it comes right apart. But what I was really surprised not to find was just tons of gook or gunk or corrosion or dirt or anything. Now, between the WD-40 and the penetrant, it probably did wash out most of it, but I really didn't find any. So that's another view of it, another close up, and you see it. That's how far the piston, if you will, travels in this bore. So, what dielectric grease may be the best lubricant and protectant. I have some, but I couldn't find it. So what I just, it was working fine with this lithium grease. I just wiped it down really good with paper towels and a shop rag, So there's the outside clean, and you see the sheen. It's still got a bit of a coating of the grease in it, and then there's the male part, if you will. Wiped it down really well, put it back together, replaced the bolts, and it's been several months now. I think that was maybe back in maybe April or May, um, and it's worked fine. So I think the long term fix, or I think the answer is there probably is no real permanent fix. If there was a permanent fix, I'd like to think the Suzuki engineers would have come up with it. Maybe the best fix, and you could convert this simply to a manual system. I know Rika offered a kit. I didn't really like the aesthetics of it. It looked awfully, I don't know, just junky. And but my preference would be just give me a lever up on the handlebar and show me how to, tell me how to operate it. But that's not what we have here. If anybody has converted to manual, I'd like to see, hear about that in pictures and whatnot. I doubt I'll do this. I'll just keep, an ear out, for it. And yeah, probably every spring or maybe every other spring, especially if you're already gonna have the tank off to do any detailing or whatever engine cleaning. It's just two more bolts. It's really not that big of a deal. Um, but that's all I have for today. So thanks again for watching. Please remember the YouTube thing, like, share, and all that. And until next time, two wheels down. Thanks, guys.